problem 18 here in section 1.1, which says, restricted by C's between 0 and 1 and D's between 0 and 1, shade in all combinations of CV plus DW. Did they tell me,
I think it's 1.5.
did they give me a,
It's that.
it's this picture,
Yeah.
right?
Yeah.
Okay,
Yeah.
they gave me a picture.
Oh, yeah.
Problems 15 through 19. Use that picture.
Yeah.
Okay, so here's my picture. I'm supposed to shade in all the combinations of CV plus DW where those two weights are between 0 and 1. You guys with me? Okay, so what is the smallest weight I can assign to both vectors?
0.
0. So if I do 0V plus 0W, where am I at?
0 is 0. Origin.
Okay, origin. Boom. Are you with me on that? Okay. Now, multiples of, say, V between 0 and 1 are allowed, right? So, this vector is allowed?
Yep.
So is that one? So is this one? Can I get past the end there?
Yeah.
Not until.
That would be
Because
greater
it's
than 1.
bounded by 1.
Yeah, so I can't get past the end of V except by using W.
Yep.
You guys see that? So if I think about adding little bits of W,
You can extend.
so if I go to V, so I'm going to do 1V plus some amount of W, right? Some amount of W looks like a little vector like this, yeah? So I'm going to go out V, and then I'm going to go up some little amount of W. You guys with me on that? So that applies though to all of the little bits of V that I went out, right? So like, I don't have to go all the way to the end of V to go up that little bit of W. I could go out like a little bit of V and then go up a little bit of V. You guys with me on that? And then we could do that with slightly longer things. Just feeling me on this? Okay. If I go a bit longer, I might get things like this. What's the furthest we can get away from the origin here?
V plus W.
Okay, V plus W. Okay, so I think in this picture, that is the furthest I can get away. You guys see that? Notice in all of these I've been thinking V first, then W.
Yeah.
Does that matter?
No.
No, not at all, right? So another way to get to this spot would be to go up some W and then over some V. And notice that the concepts of up and over here are a little bit trash.
Just thinking that.
What's up?
You guys with me?
Yeah.
Like I'm thinking of W as being kind of generally up and V as being generally over. That doesn't have to be the case, right? You guys on
Yeah.
board? Okay. So all told here, I'm going to get this section of the plane shaded. Good,
So,
good?
I guess my only problem,
Okay.
like, would be trying to figure out how to write a proof of that. So would you just be like, okay, we're given half of V and half of W. If we make it 1V and 1W, then you see it's a full parallelogram. And if you just kind of put C and D on a slider, you see that it fills up the whole parallelogram eventually.
Yeah, that's a perfectly reasonable explanation.
Okay.
I would probably personally just go with something along the lines of, here is some arbitrary point in here, right?
Yeah.
Now, if I want to get to that point, I go over by this amount and up by that amount. And both of those are necessarily less than 1 and bigger than 0 in scalar values, or for scalar values. You guys with me on that? And then I might include a little explanation of why you can't get outside this box. Like, how do I know this is enough? Well, I know I can't go over here because
Restricted.
I can't get any further than V plus some amount of W. On this one, I'm really looking more for a picture than that full-blown explanation.
Oh, okay.
But if you want to give me that explanation, it's that same thing about little bits and little bits.
Yeah.
Good with this?
Mhm.